Okay, we're picking up where we left off in the previous video. We're going through this section in the algebra textbook on complex numbers. We were just in the previous video, we were introduced to complex numbers or imaginary numbers. Now, in this video, we want to go through the how to perform fundamental operations with complex numbers. So how do we add, subtract, multiply, and divide complex numbers? And when it comes to powers, we're not going to look at powers in general of any complex number. We do that in trigonometry, like 3 plus I to the fourth power. But we are going to look at powers of just I here in this section. Now, as I mentioned at the end of the previous video, you might be wondering, well, why do we need to, if these numbers, if complex numbers, as I've emphasized, are obey these fundamental properties of numbers just like any other number, right? These absolutely do. Complex numbers obey these properties 100% like any other number, and these are fundamental to everything we do in algebra. Then why do we need to relearn? Why are we studying adding them, subtracting them, etc.? The only reason is because, and you can kind of think about how, in general, when we get to like the full complex analysis course, we're going to have to kind of do this with complex numbers, go back through everything we learned through algebra and look for these subtle idiosyncrasies, you could say, or just, you know, there's things that are not quite in perfect conjunction as what we would expect, as what we developed with real numbers in algebra. It has nothing to do with the fact that complex numbers aren't numbers and don't operate fully like numbers. It's just because of the form is different. It's because of the fact that, okay, we had, everything we learned with real numbers, it was like, okay, we're adding 5, or we start with 5. Okay, like, yeah, here's a good example. Like, okay, so we start with, let's divide 10 by 5. Well, okay, here's the form, right? We have this number 10 and this number 5. We're dividing them. Okay, that's 2. Right? Well, the form of a complex number is different. So if we're going to divide two complex numbers, we might do something like 5 minus 3i divided by 2 plus 7i. Well, okay, well, we know with properties of division, we can't do this. Like we can't separate it like this. We have to, the form is different, right? So the mechanics of, we're going to learn how to divide complex numbers later in the video. We're going to use the same properties that we would normally use for the same multiplication properties like we would do for any other number. It's just the mechanics are going to be different, right? Because it's this form of complex number is different from the form of just a pure real number. That's it. So again, you can see how we're going to have to still kind of, when fully learning how complex numbers integrate into everything we develop here in algebra and trigonometry, etc. Most of the time, it's going to be a seamless transition, right? You just apply the formulas, the properties that we develop in all of algebra. You just extend that straight to complex numbers, no problem. But there are going to be a few subtleties that we need to be aware of that, okay, it's a little bit different with complex numbers, but it has nothing to do with the fact that they're not numbers. It's just because of the mechanics. That's the only reason. Okay, so now let's start with powers of complex numbers. So if you've got any expression, complex expression with i's in it, if you have an I raised to any power other than 1, then you can simplify that. Any power other than 1. You can simplify that. Even if it's like I to the negative 1, okay, which would be 1 over I, right? It's just a number like any other number. You can simplify this. Okay, so how do we simplify I to, we can start with just like a positive integer power. Yeah, so we're not thinking about I, we're only looking at I to integer powers here. I to integer powers. Positive or negative integer power. So let's start with a positive integer. How do we simplify I to a positive integer power? Well, okay, what we're going to take advantage of is, so if we have I to the first, we know that's equal to I. Okay, now let's keep going. Well, I squared by the definition of I is negative 1, okay. What would I cubed be? Well, we can write that as I squared times I, which is negative I, okay. What's I to the fourth? Well, that's I squared times I squared. That's negative 1 times negative 1. That's just 1. Okay, and what we're going to see if we kept going, this pattern is going to repeat forever. We're gonna out of the 5th is going to be I, out of the 6th is going to be -1, out of the 7th is going to be negative I, out of the 8th is going to be 1. And so what we're going to take advantage of mainly is this I to the 4th being equal to 1. And the fact that any power of I that's divisible by 4 means that that's going to be equal to 1. So what we can do is we can separate if we have like I to the 50th. Well, we can see, okay, well, what number is, we see, okay, is 50 divisible by 4? Yes or no? If it's not, then we see there's going to be a number below 50 that's divisible by 4. So how do we find that? Well, we divide this by 4 and see what the remainder is. If the remainder is 0, then it is divisible by 4. Okay? The remainder is 2. So that tells us that, okay, we know then that we can write this as, if we subtract 2 from 50, we get I to the 48, okay? And so we can rewrite this way, right? This is valid. Well, we know I to the 48 is 1. And so we're left with I squared. We're always going to be left with either I to the 1st, I to the 0, if it's divisible by 4, I squared or I cubed every time. We're going to be left with one of these 3. So we can just come here and see, okay, well, which one is it? This is I squared. This is -1. So I to the 50th is -1. That's the idea. Now, for a negative integer power, so let's do these first 3 examples first. So I just did I to the 50th. Let's do I to the 48th. Well, okay, 48 is divisible by 4. This is going to be equal to 1. Okay, what about I to the 23? Well, we could divide this by 4 and look for the remainder, but we can actually do this in our heads because I to the 20th, right? The remainder, if we divide 23 by 4, the remainder is going to be 3. So we know 4 times 5 is 20, and then 4 times 6 is 24. So I to the 20th times I cubed, I to the 20th is 1. What is I cubed? That's negative I. Okay? So that's positive integers, but now what about negative integers? So, okay, here, the example they give is I to the -19. Okay, so the way we're going to do this is the key here is to realize that, so I to any negative power that's divisible by 4 is also going to be 1. Why is that? Because, okay, I to the -20, you can write that as 1 over I to the 20th. Well, I to the 20th, 20 is divisible by 4, so you've got 1 over 1. This is equal to 1. So what we're going to do is we're still going to use I to the 1st, I to the 2nd, I to the 3rd, because we can separate this. If we have I to the -19, we kind of go in the reverse. We see, okay, what number, if this was positive, we would be saying that, okay, so 4 times 5 is 20, so we'd separate this into I to the 19th times I to the 1st, right? Well, we're going to go in the other direction. We're saying, okay, we're going to say that we can write this as I to the -20 times I to the 1st. You see, -20 plus 1 is -19. Well, we know, again, this is 1. We're left with I to the 1st. You just go, it's the same exact thing, but you go in the other direction. Like you're going to be, you're just trying to separate it into I to the 1st, I squared, I cubed by some negative number that's divisible by 4 power. Okay. Now, adding and subtracting complex numbers. This is actually really straightforward. This is, when it came to dividing complex numbers, the mechanics are different. With adding complex numbers, it's like just addition like we normally work with, because we can see A plus BI plus C plus DI. That's 2 complex numbers, right? Well, how do you add these? It's just like combining like terms. You're going to get A plus C plus B plus DI. And there's your new complex number. And if you're subtracting, well, then in that case, it's just, you need to distribute the negative here. So you're going to get A minus C, and then, let's see, it'll be plus, and then B minus DI. Really straightforward. We'll work example problems in the next video, but this is really straightforward. Okay, multiplying complex numbers, straightforward as well, because there's no mechanics issues that complicate it. Like, so if you've got here, they give the example minus 1/2 I, then times 4 plus 6I. Well, we just distribute and multiply. These properties here apply to all numbers in the complex plane. So you just distribute, and then the thing to remember is that if you end up with a power of I that's not 1, then you can simplify it. So okay, minus 1/2 I times 4 is minus 2I, and then let's see, and then we have minus 3I squared. Okay, but now we can, I squared is negative 1. Okay, now we can't simplify this anymore, so are we done? Well, no, the only issue is it's not in standard form. You want to put it in standard form. There's nothing wrong with this. It's not mathematically incorrect. It's just not simplified by technically. You want to be able to see, we multiplied the number, the complex number 0 plus minus 1/2 I by the complex number 4 plus 6I. We want to see the resulting complex number that came out of it. Okay. What about minus 2 plus 6I and then times 4 minus 3I? We'll just distribute. So minus 2 times 4 is minus 8 plus 6I plus 24I minus 18I squared. So minus 8 plus 30I plus 18. Minus 8 plus 18 is 10. And there we go. Okay, now next it says we make use of special case products. So yeah, all of the idea that we talked about in pre-algebra, like a plus b squared, etc., that's just the distributive property, and everything we used to develop these formulas came straight from these properties here. So we can apply those to complex numbers, no problem. So so if we had 3 plus 4I squared. Well, this was like the a plus b squared, right? The perfect square trinomial. You get a squared plus 2 times a times b. So 2 times 3 is 6. 6 times 4 is 24. Plus b squared. That's 16I squared. Okay, 9 plus 24I, but like we can continue to simplify in this case because I squared is negative 1. 9 minus 16 is minus 7. And there we go. Okay, but now what's interesting is here we've got, so let's see, 5 plus 2I times 5 minus 2I. Okay, well, what is this? Well, this is the a plus b times a minus b, right? We're multiplying conjugates. In this case, we're gonna end up calling these complex conjugates, right? Now, it's not just conjugates; it's complex numbers that are conjugates. So, what we saw here was that what you get when you multiply conjugates is this difference of squares. So, well, why is this interesting? It's interesting because okay, a squared is 25. What is b squared? That's 4I squared. Okay, I squared is negative 1. Well, look, we get a pure real number. We multiply two complex numbers and we get a pure real number. So that's interesting. And we're actually going to use this to divide complex numbers. So yeah, here it talks about complex conjugates and the fact that when you multiply complex conjugates, what happens is the final result is it's the sum of the squares of the real and imaginary part. Yeah, when you multiply complex conjugates in general, or not complex, any conjugates, a squared minus b squared, but they're just referring to the fact that I squared is negative 1, so you end up with this. If you're just looking at the coefficients, the real part and the imaginary part, if you multiply complex conjugates, just take this squared and add it to this squared. Okay, so with that then, we can use this property to divide complex numbers. So how could we divide the complex number 8 plus 2i by the complex number 3 minus 5i? Well, okay, let's multiply by 1 in the form of the complex conjugate of the denominator. Now, why do we want to do this? Because, okay, the denominator, you're going to get 9 plus 25, which is 34, right? Now, in the numerator, you're going to get 8 times 3 is 24, plus 40i plus 6i is 46i, and then plus 10i squared. So 24 minus 10 is 14, so 14 plus 46i in the numerator. Right? Because all we did was just multiply two complex numbers here in the numerator and got another complex number. Okay, well, beautiful, beautiful. Because look, now we can do this. And if we simplify these fractions, boom, there you go. You divided this complex number and this complex number and got this complex number. Okay? What about this here? So we've got 1 over 2 plus root 3i. Well, this is still, it's like you can think about this like dividing complex numbers because this is 1 plus 0i, right? But I mean, you know, I guess you could think about it more if you're dividing just 1 by a complex number. Well, yeah, the whole idea is we just want to get a real number in the denominator. That's what we're trying to do here. And so we can use the fact that if we multiply by the conjugate, the complex conjugate of the denominator, 1 in the form of that, we can do that. So we're going to have 4 plus, let's see, 3 in the denominator. That's 7. Okay, and then 2 minus root 3i, and there we go. 2/7 minus root 3 over 7i. Okay, now this last problem, it's not difficult, but so if we've got minus 2 divided by 5i, right? You shouldn't leave an I in a denominator, even if it's just raised to the first power, because that's not simplified. We can divide this, and so. You know, yeah, so the complex conjugate, like if you have 0 plus 5i, that's what this is, then the complex conjugate is 0 minus 5i. So you would think, okay, multiply by minus 5i or minus 5i, and that's fine, and that would work fine. But technically, you could, if you think about it, you could just multiply by, you don't even have to multiply by 5i. You could multiply by I over I. Because the whole purpose of multiplying by the complex conjugate is to get a pure real number in the denominator. It's not about the complex conjugate. It's about getting a pure real number in the denominator, just one number. That's the whole point. And so if you think about it, if for this case, we actually don't need to do the whole conjugate thing, and because what's going to happen here is we're going to get, again, you could have done multiply by minus 5i over minus 5i, and that would work out fine. But just to show you, so here you get. Okay, but what's 5i squared? That's minus 5. So you're left with 2/5 I. Okay, and so that's just a brief introduction to complex numbers. We're going to work some examples in the next video, but we're not going to, after this, we're going to move on from complex numbers. But again, like at the end of the trigonometry course, we go into a lot more depth than we did here. But in the complex analysis course, we're going to go into significantly more depth.